Hello, everyone, ReproRehab community and beyond. My name is Grace Bellinger. I use she, her pronouns, and I am a TA for the ReproRehab program. This, I believe, the third cohort, which is 2024 to 2025. Today, I will be providing a brief tutorial on handling null and missing data types in R. Note that there are likely similar data types in MATLAB, Python, and other languages. In fact, I know there's at least NA in Python, but your language, whatever you're working with, may have similar data types that can be handled in similar ways as well. A brief introduction into the four data types that are maybe not comprehensive, but most well known in this space are null, NA, which stands for not available, NaN, which stands for not a number, and then infinity, both positive and negative infinity. I'll primarily be talking about NA data types since it's the type that I encounter most in my work and that you will likely encounter as well, but I will provide a brief introduction to the other three as well. So null data types, null is an object that represents an unidentified or undefined value. It is always an empty vector. So regardless of how many null objects are in a vector, if you request its length, it'll always be 0. And null values may result from importing data with an unknown data type into R. So for example, pulling in things from SQL or other data sources, depending on what you're working with, may result in a cell being filled with null rather than perhaps it had a true value, but that is an unknown data type and therefore didn't translate well into R. So it's first of all important to identify what's causing the null values and if they're truly null or if it is an important data type that's not translating properly from whatever data source you are using. NA is a logical constant. It's, as I mentioned, stands for not available and it indicates a missing value. And similar to null, it may also result from importing data if R doesn't know how to handle a specific data type or that data type is unrecognizable or unknown to R. So you may encounter NA values if you pull in CSV files, for example, that are generated from REDCap, um, demographic variables, there are many ways in which NA appears. Similar to null, it's important to know where they're coming from and why NA values exist, but they're not uncommon in rehabilitation research, and we encounter them a lot regardless of the data type and format. There's also NaN, which is a logical vector. This stands for not a number, and it indicates impossible values, such as if you create a vector by dividing 0 by 0, it would instead fill the vector with NaN. So that's a similar data type to Na, though different in important ways. And lastly, we have both positive and negative infinity, which may be a placeholder for very large numbers. So I don't encounter this too much in the data that I work with, but some of the data sources we have access to and play around with in ReproRehab include EEG and EMG data. And those typically, that's at least where I've most commonly seen infinite values. If they're very large number with many digits, then it may instead be replaced with infinity. And infinity indicates two things. First of all, that a value is not missing, so there is still a value there. And secondly, that it is, in fact, a number, which is important. Each of these have logical functions that can be used to identify them. And in all cases, it's just is dot whatever data type. So I'll be showing a little bit later, I'll switch over to R and demonstrate is.NA, but it's important for that one in particular, it will respond true for both NA and NaN values. So these These functions will return a Boolean function, meaning that it's a vector of true and false, depending on whether or not the statement is true or false. But if you run is.na on a vector or data frame that includes both na and nan, it will report both as true. However, that's not the case for is.nan, which will only identify the NaN values. So it's important to know if your data type might have both Na and NaN values. So you can decide whether or not to handle them similarly or differently. So first of all, locating NA values. As I just shown, we can first of all use is.na, which will give us a vector indicating true or false values. That's not super helpful if you have, say, a vector that's hundreds of columns wide, or you have an entire data frame and want to get a sense of how many NA values there are. So you can instead use sum or request that R give you the sum of the is.na function, which will report just a single value. So how many NAs are in the data frame or column, whatever that you are asking about. Beyond just the total count, you can also ask R to tell you where the position of those NA values using which, and I will demonstrate all three of these separately, or excuse me, later when I switch over to R. And there are many ways in which you can handle missing data. It's important to consider the different options before diving in and taking action because it really depends on your data source, what NA means in each case, the goal of what you're trying to accomplish with the analysis, and how much NA values may muddy results or actually change the meaning of your results. So get a handle on your data before making any rash decisions, but there are multiple ways in which you can handle missing values. So many functions can ignore NA values, and I will show what that looks like using an argument. And but before that, you also should just consider whether it's appropriate to exclude or replace NAs. And in some cases, that's a personal decision, but it really depends on if NA indicates, for example, if your data is biased to report NA for, say, certain participants or patients, then you'd want to consider that, and whether or not NA is synonymous with zero or another value, for example. So here I'll say a little bit more about what I mean. So some instances in which you may want to remove rows or records with NA. So for example, if you are running a regression analysis and one of your participants is just missing the outcome measure of interest, so you don't have a value for what would be the regressand or what you're trying to predict or explain the variance of. So if an essential variable like that is missing, or some other critical covariate or something like that, then you may want to consider just removing that participant, measurement, patient, whatever from the analysis, and that could be totally appropriate. And you may have the sample size, for example, to delete a few folks, even though it's unfortunate to throw out any data. If they're missing really critical measures, it's understandable. You can also consider removing an A, or in this case, ignoring it when you're reporting descriptive statistics. So, for example, if you are reporting descriptive statistics for demographics, such as sex, gender, race, education levels, sometimes you will have NA, whether you are pulling those data from, for example, an electronic health record, or you did not fill it in when collecting data prospectively. You don't need to exclude participants if they're missing, for example, their self-reported race. But when describing descriptive statistics, actually, I'll save that example for a little bit later. It's more so appropriate for numeric variables. So, for example, if you're interested in reporting average age and for whatever reason you don't have one of your participants' birthday to calculate age at whatever day you evaluated them, then most likely it's ideal to just report the average age as well as a measure of variance like standard deviation, just ignoring anybody that had an NA value. That's a better example than the race. I'll instead use, for example, race on the right side, talking about replacing NA. So, as I was saying, if something like gender, race, or highest level of education is missing for a participant, you again don't want to exclude them from the analysis so long as those aren't absolutely critical variables, but when you are reporting, table one, just highlighting the demographic breakdown of your participants, I tend to lump a lot of NAs into an unknown. So, for example, if we're talking about race and one participant has NA and is missing that variable, I would just have the ends and breakdowns for the known races, such as white, black, Asian, whatever else. You might have a mixed or multiple race, or two or more races, and then I typically report the N and percentage for unknown. So if there are multiple NAs, including them all together. And another case in which it may be appropriate to replace NA is when NA means the same as zero, but that is not always the case. And it's really important to think about what zero means in your data set and what NA or missingness really means. So, for example, for outcome measures, such as Fuglemeyer. So Fuglemeyer is a common motor assessment done for both the upper and lower limbs. Say I'm using clinical data and one of the patients in my cohort is missing a Fuglemeyer score. So when I pull the data set into R, that patient has NA in that column for Fuglemeyer total score. Now, I'm using this as an example of I do a lot of electronic health records research, and we have our clinicians administer a standard battery of assessments. And Fuglemeyer can be very time intensive, particularly the upper limb. So there are times in which it was skipped either because it was not clinically appropriate or because the clinician ran out of time to administer it. So in that cases, there will be an NA for the Fuglemeyer score. So when we pull that into R, in that case, it should not be replaced with zero under any circumstances. And that's because with the Fuglemeyer, as with many clinical outcome measures, zero actually means something, so long as it's a possible score, which it is in the Fuglemeyer. It's very severe levels of impairment to get a zero, because that would mean you pretty much don't have any movement as well as the absence of reflexes. But for example, if we did replace NAs with zeros and then are reporting, say, the average Fuglemeyer score for the entire patient cohort, then that NA being replaced with zero will actually drag down the average inappropriately, because it's not that they scored a zero, they don't have a score at all. So that is a different thing. And in that case, it'd be really problematic to be replacing NAs with zero. And in general, that's the case for a lot of standard outcome measures. So just consider, again, the range of values that your variable has. And if zero means something, otherwise you could also replace it with something out of range. Like for example, when I get into R, I'll show an example in which NAs are replaced with 99, just so that when you're creating tables or whatnot, N 99 is an impossible value on something, for example, like the upper extremity Fuglemeyer, and then no, it's actually truly missing rather than being a value that you inputted inappropriately. There are, however, some cases in which NA is appropriate to replace with zero. So I'll give an example of that as well. I am doing a large analysis of Medicare claims data using R, And this is looking at Medicare beneficiaries with a diagnosis of acute low back pain. And we're interested in many different outcomes within a 90-day period. And one of the outcomes is number of physical therapy evaluations. So I know from procedural codes when a physical therapy evaluation is billed to their Medicare insurance. And I have a for loop that's actually summing up any rows or claims that indicate a physical therapy evaluation. Now, if a beneficiary doesn't have um, any physical therapy evaluations, then depending on how I write the code, there, excuse me, their sum may fill in with NA. And in that case, the absence of a sum score truly means zero, or it is synonymous with zero. It means that there wasn't anything to sum, therefore replacing it with zero, it totally makes sense and is perhaps a bit clearer in the analysis. But again, it really depends on the data you're working with, the possible values, the range of values, and if something like 0 or 99 is a meaningful value for that variable, then you should really consider whether or not you want to use a number at all, or instead just leave it as NA. So that's my warning to you to just to make sure you're considering the options, and regardless of whether you choose to replace or remove them, obviously always save the raw data that has the NAs in there because you wouldn't want to overwrite something, save it, or delete rows and save it and then lose the actual raw data if you decide to include them in a different way or a subsequent analysis. So that's just my soapbox about knowing your data and how best to analyze it. Here are a few functions which can be used to remove or ignore NA. I will give a brief demo of NA omit, but there's also NA fail, which will actually stop the code if an NA is detected. So if, for example, you're writing a really long script and you just want the code to stop if it encounters any NAs, that's a great one. You can also use NA exclude, which operates similarly to NA omit, except it actually keeps an index of the position of the NAs. And then NA pass just ignores them. So proceeds as planned, the code continues to run, and it just ignores any NAs. For replacing NA, I will give a demo of this over in R, but really the simplest way is to use the replace NA function from the dplyr package, which I will show in R. There are other ways, but this way is honestly pretty foolproof, and you can even use it within if then statements or whatever. So I haven't really had to look for other options because it is so robust, this function. You can use it on multiple functions, or excuse me, multiple columns. Sorry. You can use it on multiple columns. You can use if-then statements. And so it's a really great function to just replace those again if that's the most appropriate path. All right, so now I will switch over to R. All right, hopefully you all can see that. I recognize it's a little small, possibly. Um, I just have a few lines of code here to demonstrate some of the various things that we've been talking about. So first of all, if you ever want more information about a built-in function or data type in R, you can always type in this question mark and then whatever you're curious about. So if I run that, down here in the corner is where the information will be. So this will actually tell me a bit about not available values. Similarly, I can do that for the infinite values. And so if you're ever in need of a quick description something you encounter, you can actually search it within here and ask for help within R itself before going to Google to look at forums or R documentation. Okay, so I'm first going to create this vector shown here, we'll call it X, that has two NAs in it at the first and fifth position. So when I run that, you see it show up over here, and the NA values are so it's a numeric vector, but you can see that there's the NAs in there. Some of the functions I showed included is.NA. So if I am, first of all, just curious, say this was a very large vector or a very large data frame, and I wasn't sure if any NAs existed, I could use is.NA and then enter in whatever column, datum frame, vector, whatever, and it's going to return this Boolean. So it's saying that for the first one, it is true, which is correct. The first entry is NA. Then there's three falses where I have, real values 1, 2, 3. Then another true at this NA, and then two more falses. So that's just showing how it operates. And again, I believe it's NA that is.NA that will actually respond true for both NAs and NANs. So just be aware of that. So knowing that they're there may be helpful enough, but you may also want a sense of how many we're talking about. Is it just one? Is it hundreds? So requesting the sum of that will show, in this case, we only have two NAs. And I use this sum is that NA a lot in my code, particularly where I am removing or replacing NAs, because I will have a line of code requesting the sum, and then after whatever processing step I'm using, for example, to filter out the NAs or handle them, then I will run the same line of code again and ideally get 0, so indicating that all of the NAs were handled by whichever method I decide. So that's the sum is.NA, and you can also, if you want to know their position, use this which function, which here gives us the first and fifth positions, which is correct. So that's just a few of the basic functions in identifying and recognizing how many NAs are in your data set and where they are. Here I'll give an example of when a simple function can just ignore the NAs. So first of all, say, I have these 7 values, 2 of which are NA, but I want to find the mean. And so if I just do the mean of X, mean is a built-in function, it's going to give me NA as the result, which is not what I want. I actually just want it to ignore the NAs and give me the average of the values that are not NA. So this function and many others, as I had said, have an argument that you can pass, this na.rm equals true. That just stands for NA remove, and in this case, putting true will tell it to ignore the NAs and just calculate the mean for any non-NA values. So once I add that argument, it outputs 3. So it ran properly and it gave me 3, which is the arithmetic mean of those 5 non-NA values. So that's a short and sweet way if you're just, for example, interested in reporting descriptive statistics of your participants and know you have a few NAs for age or time since stroke, some missing values, then the na.rm equals false is very helpful. Or excuse me, na.rm equals true is very helpful. One of the ways that I had shown to remove NAs is this NA omit function. So in this case, I'll take our trusty X vector that has 2 NAs in it and pass it to Y, or rename it as Y, but using this NA omit function. And when I do that, you can see that up here on the right, we have Y again. Now there's only 5 values, and they are all the numeric values. The NAs have been removed. So that's just showing how NA omit works, but this is just a simple vector. And something that's important to note is if you have a data frame and use NA omit, then if there is an NA anywhere in any column, then it will actually remove the entire row of data. So I encountered that a bit with some of my learners this year, in which they weren't realizing why data frames were becoming zero or really small sample size. And it was because if an NA was found in any column, then it was actually removing the entire patient or participant or repeated measure, whatever. And that's actually not how they wanted to handle it. So just be aware that NA omit is removing the entire row. And then another way, so the simple code to replace NA, you would run these two lines of code to install dplyr, which replace NA is built into. Here, I am just taking the NA values from X. So again, X has two NAs and replacing them with 99 in this new vector called Z. So I printed it down here. You can also see it up here. Instead of the NAs, it just has 99, which would have to be a value that isn't possible in the raw data. So I would be certain that that's actually just representing missingness that I have replaced with 99 for the purposes of identification or whatever reasoning I may have had. So that is my very brief tutorial on missing data types and how to handle them. There's many more complex ways to handle them, but really replace NA, NA omit, and NA.rm will get you very far in terms of handling NA values and processing data that inherently has NA. Most of the data sets we're working with do, so just know that if you have NA values, there's no reason to give up or feel hopeless. Every data set has missing values in some way, and that's just something that we have to handle through the processing. Thank you so much for your attention, and feel free to email me if you have any questions. Thank you.